Okay, so we are going to talk about the angle relationship in parallelogram. We're going to take this lesson right into some special quadrilaterals, which are also parallelograms. We just finished parallel lines with transversals and all of those relationships and those angles. So we're going to take those same concepts, build on them inside a parallelogram, and then we're going to take those concepts and build on them in quadrilaterals in the next lesson. But a parallelogram is a shape that has specifically opposite sides are parallel and therefore opposite angles are congruent. That is what a parallelogram is. Now let's backtrack just a minute and let's look at two parallel lines. And imagine that we had two transversals with those parallel lines. And just assume our transversals were also parallel. If you ignore the outside of this, what you have is a parallelogram. The exact same rules, postulates, patterns of same side interior, alternate interior, all of those things are still true because we have simply only taken a segment of that line and are using it as a side of our parallelogram. So we're going to ignore these continuations of these lines on the outside. We're only going to look at the parallelogram on the inside. So all of these shapes are no more than two parallel lines with two transversals that just also happen to be parallel. All parallelograms are kind of that situation. So we're going to look at some of the problems on our worksheet specifically. Okay. So the angles in the parallelograms are no different than the angles with two parallel lines and a transversal. So on this worksheet, if you will just imagine all of the lessons that you've just done, here's a parallel line, here's a parallel line, and then you have the transversal. The transversal just happens to also be parallel. So you could actually take this and rotate it 90 degrees clockwise, and it would be more of the orientation that we're used to looking at with the parallels and the transversals. However, let's look at this. So we're going to compare this angle to this angle. Those are same side interior angles. What do you remember about those? They are supplementary. Anytime you have two parallel lines and a transversal, same side interior angles are supplementary. Therefore, this angle at the top must be 75 degrees because supplementary means they add up to 180. That has to be a 75-degree angle. Now let's rotate that picture 90 degrees clockwise, and you have another pair of same side interior angles here and here. Therefore, the question mark or the missing angle is also 105 degrees because it's supplementary to 75, meaning they add up to 180. So that missing angle is 105 degrees. Correct answer on that would be D. Those are the same properties that you're going to use repeatedly on this worksheet. Let's scroll down a little bit and look at some of the more difficult ones at the end. For example, number 13. Imagine again two parallel lines and a transversal. And if we look at the two pink lines as our parallel and the red as a transversal, this whole entire angle right here is supplementary to 60. So the whole pink angle is 120 degrees. Because that's what interior same side angles are when you have two parallel lines and a transversal. Therefore, 4x minus 1 plus 93 equals 120 degrees. Now we have a basic algebra equation. So we're going to subtract 93 from both sides. So 4x minus 1 equals 27. Then we're going to add 1 to both sides. Those parentheses don't mean anything anymore because there's nothing happening on the outside. So 4x equals 28. We're going to divide both sides by 4. X equals 7. You want to repeatedly use what you learned in parallel lines over and over and over on this worksheet and practice that concept. And those would cancel out. Correct answer, B, X equals 7. Now, one thing I will caution you on this worksheet is, for example, number 15. This is actually referring to this angle right here. It was just too long of an expression to make it fit. So you might think that it's talking about the length of a side. That is actually the measurement of that angle. So be careful when you're looking at those. That is that angle. If we scan down this worksheet, there may be some more that are kind of like that. Let's look at number 23. So we have FJ is 2x plus 7. That's this today. Segment right here. That's 2x plus 7. JH is 3x plus 3. And we're trying to find FH. What do you know about the diagonal of a parallelogram? They bisect one another. Therefore, those are the exact same length. So 2x plus 7 equals 3x plus 3. We can subtract 2x from both sides, leaving us with 7 equals x plus 3. Then we're going to subtract 3 from both sides, leaving us with 4 equals x. Well, they didn't ask you what x was. What they asked you for was, what is FH? Well, FH is 2x plus 7, so it's 2 times 4 plus 7. That's 8 plus 7, which is 15 on, excuse me, that was JH. What is FH? When we find the length of one of them, FJ is 2 times 4 plus 7, so FJ equals 15. They're identical, so JH is also 15. What is FH? FH is the whole diagonal length. So it's both of those added together, which would be D 30. That's the things you're going to do on this worksheet over and over, applying all of the same things that you know about parallelograms. So one new thing is the diagonals of a parallelogram, every single one of them, bisect each other. One last diagonals always bisect one another. And we use that in that very last problem. That's one last characteristic of parallelograms. And another one is the diagonals of a parallelogram divided into 2 congruent triangles. So they divide the parallelogram or the shape into 2 congruent triangles. Now in our next lesson, we will look at some additional qualities based on what kind of a parallelogram it is. But in this one, what we need to know is the diagonal is that segment that connects opposite corners. So there's one diagonal, and here is the second diagonal in blue. Those diagonals always bisect one another, always. So this segment always equals the same length as that segment, and this segment always equals the same length as that segment, because that's what diagonals in parallelograms do. Remember, these are parallelograms. These lines are parallel to one another, the one that has the matching marking. Anytime you have opposite sides parallel, you have a parallelogram, and that means opposite angles are congruent. So a diagonal will always bisect each other or cut each other exactly in half, and it also always cuts the triangle into 2 identical, cuts the parallelogram into 2 identical triangles. So if we just look at that brown diagonal, it would cut the triangle into the red and the green triangle. And if we look at that blue diagonal, the blue diagonal cuts that parallelogram into 2 congruent triangles, the red one and the green. It does not necessarily cut it into 4 equal triangles, but definitely into 2 big congruent triangles. One diagonal makes 2 equal triangles. And on this worksheet, you're going to upload pictures of handwritten notes. You're going to show all your work. You're going to have a lot of algebraic equations. Draw the picture, write the equation out, show the solution. Use homework help for the ones that you struggle on. And then you're going to put all your answers into the multiple choice, for your multiple choice into the Google form. Okay, see you in the next lesson.